General technical requirements for instrumentation for packaged equipment. General packaged instrument and control systems shall be designed to operate within the performance limits specified or agreed by the company, ensuring minimal maintenance costs by considering the availability of skilled personnel on site. Instrument systems should be designed to avoid interaction between associated electrical circuits and suppress spurious signals that cause interference. Instruments must be numbered according to the piping and instrumentation diagrams used throughout the job, with deleted item numbers not reused. The package should be designed for failsafe unmanned automatic operation unless specified otherwise by the company. Package panels shall be PLC-based, rated to IP66, located in the field, and suitable for hazardous area classification to Zone 1, Group 2A IUB, and Temp Class T3. All instruments must comply with the electrical classification of their installation area and be certified accordingly. Communication transmitter communication should be 4 to 20 milliamps two-wire. The PLC shall communicate with existing DCS equipment using Modbus RTU protocol via RS-485 redundant serial link. Start-stop trip signals from DCS ESD systems to the package unit shall be hardwired through potential-free relay contacts rated at 24-volt DC 0.5 inch. Performance. The rangeability of the instruments shall be as specified in the attached data sheets, with errors expressed as a percentage of the calibrated span unless stated otherwise. The transmitter accuracy, including the combined effect of linearity, hysteresis, and repeatability, should be equal to or better than the figure stated in the attached instrument datasheet. ESH instruments, pressure gauges, board and tube type for general local pressure measurement. Gauge cases should be aluminum alloy, weatherproof, and black painted with 4.5-inch diameter dials. Gauges should have over-range protection to 25% above maximum pressure and be liquid-filled for vibrating installations. Instrument process connection should be half-inch NPT. Pressure transmitters should consist of a diaphragm or bellows with a capacitance capsule or electrical strain resonance frequency transducer unit equipped with local digital indication. Transmitters should have non-interacting zero and span adjustment and integral 3-valve manifolds, certified for the electrical area classification. Temperature. Thermowells. Installed in flanged thermowells designed according to BS 2765 with materials as per process conditions and should meet hydrostatic testing conditions. Wake frequency and stress calculations should be provided according to ASME PTC 19.3. Temperature gauges. Bimetallic type with rigid stem suitable for mounting in flanged thermowell, 4.5-inch diameter dials and aluminum cases. Temperature transmitters. PT 100 RTD for ranges between -200°C and +400°C with integral temperature elements. Remote transmitters should be used in cases of high vibration or poor access with IP66 and XD or XE certification. Solenoid valves function as pilot devices only, with encapsulated high-temperature coils, 3 and 6Nel stainless steel bodies, rated for 24-volt DC, and seal materials of Buna N or Viton. Relief valves. Designed, constructed, tested, and marked according to API 520, 526, and 527, with balanced bellows or pilot-operated safety valves for specific applications. Overpressure limits should comply with SME 8 standards, and installation should consider direct and unobstructed flow between the vessel header and the valve. Local control panel. PLC-based control system for monitoring and control, EXT type for specified hazardous area classification, with front door access and integral sunshade. Wiring should be low smoke emission, halogen-free, and flame retardant, with provisions for online testing without affecting operation. Tubing and fittings. All instrument tubing and fittings shall be SS316, with process fittings rated at a minimum of 3,000 SOPR. Tubes and fittings should be a minimum of half-inch with 0.049-inch wall thickness, using double compression flareless type fittings from approved manufacturers. Installation of instrument tubing. Impulse lines should be as short as possible and preferably in the vertical plane. The slope should be 10 mm per 200 mm length, with supports and trays arranged neatly for self-draining and minimal dirt collection. Welding supports to process piping or vessels is not permissible. Instrument cables and ancillaries. General. Stranded copper conductor cables are preferred. Underground cables should be XLPE, PVC EPR insulated, lead sheathed, single galvanized steel wire armored, and PVC CSP oversheathed. Segregation of signal cables. Intrinsically safe signals should use multi-core cables with distinct color coding and appropriate segregation from non-IS circuits. Instrument cable glands should be isometric thread metallic brass with nickel plating, dual certified to EEXD and EEXE, and weatherproof to IP66. Cable trays must allow access to equipment and avoid blocking walkways, with 0.5 meter separation between cable groups where possible. Perforated steel or aluminum trays should be used, with a minimum of 25% spare capacity for future installations. Earthing and bonding. Earthing conductors should be stranded and insulated, with separate bars for safety and instrumentation earths, and appropriate bonding for metallic instrumentation enclosures. Labeling and ferruling. All control panels, relay boxes, and terminal boxes should have nameplates with engraved labels. Instrumentation should have permanently affixed stainless steel labels with tag numbers, and field instruments should have traffolite labels with tag numbers and service. Cables will contain only tag numbers. These general technical requirements ensure that the instrumentation for packaged equipment meets operational, safety, and performance standards for reliable and efficient operation in specified environments. Quality assurance, inspection, and testing. Quality assurance. The vendor shall comply with all QA/QC requirements specified by the purchaser. Workmanship, materials, and quality control must be of the highest standards. The vendor must demonstrate an effective quality system in accordance with an internationally recognized standard. This system and the vendor's compliance with it will be monitored and potentially audited by the purchaser. A quality control program must be submitted for review at the time of the tender. The vendor shall provide facilities and cooperation for inspections and testing during manufacturing, assembly, and testing. Third-party design verification may be required at the vendor's cost. General. The purchaser or its representatives must have free access to all parts of the vendor's workshops related to the construction and testing of the equipment. The vendor is responsible for all inspections and testing of materials and equipment prior to delivery. No equipment or materials shall be delivered until all applicable tests have been completed, defects rectified, and successfully retested. Documentary evidence must be available for review upon request. Inspection Test Plan, ITP. Vendors must include an ITP in their tender documents, listing all inspections and tests proposed for the equipment from the date of ordering to the date of delivery. The purchaser's representative has the right to witness any or all inspections or tests. The final version of the ITP, signed by both the purchaser and vendor, becomes part of the contract documents. The vendor must notify the purchaser at least 2 weeks in advance of any inspections or tests marked as hold or witness points on the ITP. Testing. Local control panel tests. Completed control panels and associated equipment must be inspected and tested to ensure compliance with specifications and drawings. This includes checking labels, tags, fuse ratings, circuit polarity, total electrical load, power factor, and earthing. Insulation test. All wiring must be tested for insulation with compatible test voltages. Circuits with insulation less than 10 megohms for 1 minute will be rejected. Sensitive equipment must be disconnected during testing. Simulated functional test. Equipment must be energized for the duration of the test, including externally powered panel-mounted indicators. Dummy loads should be fitted where necessary. The test must ensure the correct operation of alarms, interlocks, and time delays. Simulated signals between the local control panel and the DCS should also be tested. Instrumentation test. Skid-mounted instrumentation must undergo bench and in-situ calibration, wiring continuity and insulation tests, air leakage tests, process impulse line tests, and pneumatic or nitrogen tests. All test equipment must be certified and provided by the vendor. Pneumatic tests. Pneumatic equipment should be tested for leakage using dry air at 110% of maximum working pressure, and functional tests should verify proper operation over the full range of input signals. Electronic instrument and instrument loop test. Electronic instruments and loops should be tested from the junction box to the instrument, ensuring cables have been Megger tested and that test equipment follows manufacturer recommendations. Relief valve test certificates. The vendor must issue test certificates for each valve fully compatible with API RP520 requirements. Corrections, errors, and defects. Defects detected during testing must be repaired or replaced by the vendor at no additional cost. Major alterations require the purchaser's approval. Equipment or parts not meeting specifications may be rejected. Damaged parts must be retested, and the method of repair must be approved by the purchaser. Commissioning. The vendor should identify any special requirements or recommendations for support during commissioning. Final acceptance by the purchaser is subject to performance testing after installation and commissioning on site. Site support. Vendors must detail their after-sales support capability and provide information about their nearest service representative and facility. The vendor is responsible for executing all commissioning activities associated with the scope of supply. Training. Training for the package control system must be included in the vendor's scope, covering engineers, operators, and technicians. Protective coatings. Control panels supplied with the package must be coated upon completion of manufacture. Panels located outdoors require surface preparation, painting, and protective coatings as per the relevant standards. Packaging preservation and preparation for shipment. The vendor is responsible for packing, protection, preservation, labeling, and marking of all items. Load test certificates must be shipped with all lifting equipment. An installation and operations manual should be shipped with each equipment package. Packing. Items must be securely packed to prevent handling damage, allowing for forklift or crane handling. Equipment should withstand at least 12 months of storage at the construction site. Spare parts and special tools should be packed separately and marked clearly. Preservation. Equipment must be thoroughly cleaned and free of loose materials. Surfaces not painted should be coated with corrosion-protective grease. Openings should be covered or capped to protect against dust and moisture. Marking. A packing list should be attached to the outside of the package, showing the owner's name, address, project name, vendor details, purchase order number, item number, delivery details, contents description, and number of packages. Rust preventatives used should be listed with removal instructions. Nameplate details. Primary nameplates must be permanently attached, made from 316 stainless steel, and include the client name, project name, purchase order number, equipment tag number, manufacturer's name, serial number, model number, year built, and certified weight. Spares and special tools. Spares. The vendor must identify pre-commissioning, commissioning, and startup spares, as well as recommended spares for 2 years of operation. All spare parts must be packed to preserve items in new condition and marked clearly for identification. Special tools. The vendor should identify all special tools required for routine maintenance and specialized procedures, itemized and priced in the tender. Documentation. The vendor is responsible for providing all documentation in accordance with the relevant standards. Documentation must be submitted for review and approval before fabrication begins. General. After receiving the order, the vendor must submit a vendor document schedule listing all drawings and documents for review and approval, including those listed in the VDRL. Drawings should be AutoCAD 2000i or later, and documents should be MS Word or MS Excel. Material certificates. Certificates must be provided for mechanical equipment, lifting aids, and all pressure-retaining components in accordance with EN 1204. Full traceability of pressure-retaining welds and critical structural steel welds is required. Test certificates and test documentation. Certificates for mechanical and performance tests, along with relevant test and calibration certificates for instrumentation equipment, must be provided. Instruction manuals, handling and lifting procedures, operating instructions, emergency response procedures, key drawings, calibration certificates, and spare part lists must be included in the operating and maintenance manuals.